so a fun fact about Python, the language, not the snake, is that it isn't actually related to, the naming isn't actually related to anything about snakes at all. Well, it is actually related to a British comedy show, Monty Python, somewhere around in the 1970s, and the founder, Kiddo Van Rossum, was a fan of Monty Python's Flying Circus. So, in a very, very irreverent mood, he just named his language Python. Well, that's certainly an interesting fact. And as the mood suggests today, we are going to be starting with computer science. Computer science, and more specifically our first chapter, which is Python. For 12th, it is mostly revision tool, Python revision tool part 1 and part 2. But it's basically going through Python that you have learned in 11th and 12th combined. So, if we start with the basics of Python, let's start with the basics of Python. Now, for the basics of Python, obviously we need to know basic terminologies. So, firstly, we have tokens. Now, tokens are basically, let's say, if you were to talk about matter, the smallest possible unit of matter is an atom. Similarly, in Python, the smallest unit is called a token. Now, it could be a keyword, it could be an identifier, it could be a literal, it could be a simple, let's say, operator or a punctuator. Right? So, if I were to give you a very, very simple example, right? Let's say we were running a for loop. Okay, so if I write for A1 in range 0 to 10, right? This is a start value, this is a stop value, and I were to write if A1 mod 2 equal to 0, then we have to print A1. Okay, so now over here A1 is an identifier, while here it is a loop variable, here it is an identifier. Right, this is our condition, okay, this is a keyword, okay, this is a keyword, right, so, and then this is our operator, and this is our punctuator, right, so, these are basically what tokens are, and tokens are usually terms for the smallest possible unit of Python, okay, After tokens, we come to the use of what keywords are. Now, keywords are basically predefined words in the language or in Python that have their own meanings and that cannot be used for any other purpose than the meaning that they have. For example, if I were to use for to as a variable name to assign, let's say I want to assign a value of 4 to 1. Python wouldn't let me do that because for is a keyword. And since it is a keyword, it has only one, let's say, function. And that function is to create a loop and perform a loop function. Right? So it wouldn't let me assign a value to this keyword. For this, I'd have to either change the the case from lowercase to uppercase, or I'd have to, let's say, for 1. Anyhow, I have to modify the keyword for it to be regarded as a variable. So that is what a keyword is. There are a lot of examples of keywords. For example, let's say there is while, there is for, there is if, there is true, there is false, there is none. Okay, these are some examples of keywords, and at the end of the video, I will put a picture as to what keywords in Python are, and you can note them down. Now, after keywords, there are identifiers. Now, identifiers are names that we assign to a particular value. For example, let's say we declare x as a variable and we declare its value to be 2. Then x over here is our identifier for the value 2. Right? That pretty much sums it up about keywords and identifiers. Then we come to literals. Now, what literals are? They are data that have a fixed value. Now they have a fixed value, they do not have an indefinite value, and that they are divided into parts. Now the first literal that we have is a string literal. String literal basically means anything which you encompass or enclose within quotes. Okay, so if I were to write in single or double quotes that my name is Devi. If I were to encompass this in single quotes, then everything within these quotes is a string literal. Okay, and if I were to count the value, or if I were to count the fixed value of this string literal, then we would count it according to the number of characters, and the number of characters in each string would determine its size. It's fixed, right? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now that wasn't the correct way of counting the value of a string literal, because for a string literal, even the spaces are counted as characters. So technically, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 characters in my string, or the size of my string would be 16. Okay, now Python, there are some features of Python that we need to know. The first feature, the first most important feature is that Python has dynamic typing. Now what would you say dynamic typing is? Dynamic typing basically means that, let's say you assign a value to the variable x as 2. Okay. But further into the program, let's say you do not have any block, or you do not have any loop, and you do not have the value, you are not using the value in any function, user defined function, and then you just say you want to change the value of x, and you say x is equals to 5, and then you write print x. Then the value of x would not be 2, it would be 5. Then this would give the output to us as 5, not 2. Right, so you can change the values of the variables as you see fit. That is what dynamic typing is. Okay, then Python is case sensitive. So if you were to write, let's say for as an identifier, since it is case sensitive and this is an identifier, you won't be able to use it. But if you use this as for, then you won't have a problem, because this can work as an identifier. Similarly, let's say you give the value to small x as 2, but in the print statement you say print capital X. It will give you an error of x not defined, because we have given the value to small x, not capital X. Then after we have string literals, in string literals there are, let's say, some non-graphic characters that we can use as escape sequences. Now, escape sequences basically, if you want to insert some characters without the string getting closed. For example, let's say you want to insert a new line character, okay, or you want to get that part after that character into the next line. Then you can do that by multi-line comments or multi-line strings, which are under 3 single quotes. Okay, so anything you write between this, you can press enter and the string will go on. But there is another way to do this. You can just write your, let's say, string my name. Let's say I want to write my name, and then I want to put a colon, and then I want to write Devi over here. So when I print my string, let's say x is our string, and I write print x, and I want to print my string in this format, then over here I can just put a new line character. So this, anything after this, it will move on to the next line. Okay, and there is no need to write it over here. We'll have to write it over here, since this is a character, it will move it. But you have to write it after it. So anything after this, it will move on to the new line. Okay, so that is what the new line character is. There are other escape sequences, such as, and escape sequences are always represented with a backslash and then the character that we have to represent it. So if I were to say that there is an escape sequence called double backslash, then this basically inserts a backslash in our string. If I were to say I have to insert a single quote without breaking my string, then it would be backslash and single quote, or backslash and double quote. Now, these are some escape sequences. Usually the escape sequences that we generally use in Python is either /t or /n, okay, or these three that I just mentioned. Moving on. Now, that was one part of literals, string literals. If we move on to the other part, there are numeric literals. Numeric literals have three forms: the decimal form, the octal form, and the hexadecimal form. So the decimal form is pretty easy. Okay. Now there are basically majorly two types of numeric literals. One is the integers and one is the floating point literals. Now integers are, as you said, whole numbers, and they do not have a point in them. And floating point literals are when you can insert a decimal in the number. For example, an integer would be 5, but a floating point of this 5 would be 5.0. Okay, so that is what numeric literals are. If you've gone through your 11th courses, then you pretty much know that there are also decimal integer literals, octal integer literals, and hexadecimal integer literals. Right. Now, moving on to the other parts. There are Boolean literals, which is basically true or false or 0 or 1. And then there is a special literal none. None is basically to say that anything does not have a value. The integer value of none would be 0. Okay. The integer value of false would also be 0, or the Boolean value of false would be 0, and the Boolean value of true would be 1. So, if you were to evaluate an expression, let's say print true, and not false. Okay, so these are operators, so we'll get to this later. But just know that the mathematical value of true and false is 1 and 0 respectively. Similarly, for none it is also 0. Now, operators are your simple operators like plus, minus, again the division, multiplication. Multiplication over here is done by an asterisk. Division is done by a single slash. Then you have the modulus function, which calculates your remainders. The floor division function, which calculates your quotients for any division, right? Then there are other operators such as the logical operators, which are and or. I'm pretty sure you must have learned the logic gates of these or also know how these work. Let's say if I want to say 1 and 0. Now, like I told you, the value for 0 is false and the value for 1 is true. So, 1 and 0 basically says that 1 is true and 0 is true. Now, if 0 is false, then technically it is true and false. Now, how the AND operator works is that the AND operator always checks if both of these arguments given for the operator are true. If both of these are true, it will give you a true. If both of these are false, it will give you a true. But if one of it is true and one of it is false, it will give you a false. This will give us a false, because 0 is also identified as false. But if I were to say, let's say true and not false. Not false is true, then true and true is true. So you will get a true value for this. The OR operator does not work in this way. The OR operator basically works that if one of these is true, then you will get a true value. If both of them are true, again you will get a true value. It basically just checks for one true value, whether it be the first argument or the second argument. So if I were to say, let's say false or true. So now over here it will check that this value is false. Okay, now if this value is false, then it will move on to this value which is true. So if this is true, then our entire operation is true. The value for this operation is true. Then there are, assignment operators. For example, the assignment operator is basically equal to. Then there are other operators related to the assignment operators, which are called arithmetic assignment operators. For example, let's say you want to change the value of a variable that you have assigned to by 1. Then you can basically write x plus equal to 1. What this basically means is x equal to x plus 1. Right? Or similarly, if you want to decrease the value by 1, you can say x minus equal to 1. This will subtract a value, x equal to x minus 1. Or if you put x multiply equals to 1, then this would be x equals x into 1. Okay. So any value that you use with equal to, you are just changing that value by whatever operator you are using on it. Okay. Then obviously there are punctuators. Punctuators are simple. You use a single quote, you use a double quote, you use a round bracket, you use a square bracket, you use a curly bracket. All of these are punctuators. You use a colon or you use a semicolon. All of these are punctuators. Now coming back to our bare bones of a Python program. Now bare bones of a Python program are basically the components on which a Python program works. There are expressions, there are statements, there are comments, there are functions, and there are blocks or suites. Now block is basically, let's say, a group of statements which is part of another statement. You remember how loops worked, right? Now if I were to talk about a for loop, let's say for I in range 10. What this basically means is that the loop would run from 0 to 9 in this. So basically 10 times. Okay. And then anything that I write is after this indent over here. And then this entire thing would be a block. Now, not necessarily that the blocks are only there for the for or while loops. There are blocks also for user-defined functions that we are going to be covering later. So, that is what blocks are. Expressions are basically any legal combination of values that any legal combination of words that represent a value. If I were to say, let's say, count equal to 0. This is an expression. I think that is now pretty self-explanatory. Then statements are programming instructions. For example, you write print x. This is a statement. Again, self-explanatory. Then there are functions. Now, for example, you want to count a value out of a pool of values and you want to count the maximum of those values. Then you use the function max. Now, functions are of a few types. One is the built-in functions, and then there are user-defined functions. Okay, so built-in functions we know about a lot. Then there are user-defined functions, and then there are library functions. Now, library functions, you have to import a library to use those functions, right? So that pretty much sums up what functions are. And then we move on to variables and their assignments. Now I told you how variables are values are assigned to variables. You just put an equal to sign and then you get a value for variable. Now, for example, let's say you want to assign a value. You want to assign two values to two variables at the same time. You could basically just do this: a comma b equals to 1 comma 2. Or let's say you want to assign three variables, three values at the same time. Then you could just do a comma b comma c equals to 3 comma 3 comma 3. Or what you could do is, if you want to assign three variables the same value, you could either do a comma b comma c equals to 0 comma 0 comma 0, or you could do a equals to b equals to c equals to 0. This assigns the same value to each of the variables. Okay, that is pretty much about what variables and their assignments are. Right. Then I already told you about dynamic and static typing. I already told you about multiple assignments. Now, simple input and output. Okay. Now input and output. Input you can just basically do with the input function. Right. Input you can do it by the input function, and output you can do it by the print function, or let's say output you can put by the output you can do by the print function. So how do you input something? Okay. Generally, when you input something in Python or input let's say any expression in Python, any value in Python, that value will always be let's say accepted by Python as a string value. String enclosed between quotes. Okay. So if you want to convert it, then you have to input it within other functions. Now let's start with how we use the input function. Let's say x equals to input. You can also use comments inside your input function so as to get the user to understand what they need to input or what value they need to give to the computer to move forward with the program. Right. So for example, I want to input the user's name. I would say your name, question mark, and then question mark, and then I would close the bracket. Now functions always anything, any thing that has a parenthesis around it, anything, whether it be user defined or built-in or a library function, any word that has a parenthesis just beside it is a function. Okay, so input is a function. We can put our argument or our comment in the function, and you can input value. Now this value would be input as a string value because my name is Devi. My name would be input as a string value. But if I want to enter, let's say, an integer value, I don't want it to be string, I want it to be a number, then I will have to convert it, and I can convert it by x equals to inputting the value inside the integer function or the converted function integer, right? Int input my age, okay, and then close two round brackets. Every function is closed with round brackets. Okay, so there is a function within a function, and that is why we need to put two round brackets at the end. Similarly, you could use the float converter as we have used it for this. Now, for inputting things like dictionaries, tuples and lists, we'll come on to them later, you can use the eval function or you can use the for loop. It depends. Now, let's move on to that pretty much sums up the basic components of Python. Now there are data types. Okay, data types basically for let's say numbers is basically integers and booleans, or floating point numbers and complex numbers. Right? I have already talked about that. Then there are data types for strings, which is basically pure Unicode characters or the ASCII characters. ASCII characters, we've learned about them before. Usually we talk about Unicode characters because that is now universally accepted. Then there are lists which can accept any data type. Then tuples which also can accept any data type. Right. Then there are sets which is a mutable data type and it can take different values, but it does not have mutable elements. Dictionaries also, they can take any data type. Okay. And then there are mutable and immutable. I just use these two terms. Mutable basically means changeable, immutable means unchangeable. So, what are mutable and immutable data types? If I want to say examples, then in mutable we have list, tuple, etc. And not tuple, list and dictionaries. Okay, and in immutable we'd have a string and a tuple. These are data types that once assigned cannot be changed. Okay, or we cannot do inherent changes in them like we can do in a list, or we cannot do indexing changes or key changes in them. Okay, then we move on to another topic, and now let's start with evaluating some expressions. Now we know how to evaluate our expressions, and we know how to do it, but there are still some questions that we should try regarding this. Okay, so if I were to, let's say, give you a question about an operation. Okay, let's say I give you a question 5 how would you evaluate this expression? Now this is an exceptional case where we are using to the power. This is a power assignment in operator. So if I use double asterisk, then double asterisk basically means this number to the power this. So how we evaluate this question is, for this at least we start with the right hand side. So when we start with the right hand side, we start with 3 is to the power 2, which is 9, and then 5 is to the power 9. That would be our answer. 5 is to the power 9 would be our answer. Similarly, in other expressions also, like for example, if I were to say 3 divided by 3 is to the power 2, then first we'll solve this operator and then we'll move on to 3 divided by this. But usually there's just BODMAS rules. When the power operator is not there, there is just BODMAS rules that you use over there again. Okay, now let's start with typecasting or explicit type conversion. Now typecasting we know is how we convert values. Like I said, if you want to input a number instead of a string, or you want to input a decimal number instead of an integer, then you can do it by your typecasting or user-defined conversions. Okay, then we move on to the library functions. Now there are 3 main libraries or modules that we have learned about. The first one is the math library or the math module. So we import the math module with the statement import, and we say import math as any, let's say, m. We can import our functions as any variable so as to increase simplicity of use. Okay, then the math module includes functions that are ceil bracket, sqrt bracket, exp bracket, fabs bracket, floor bracket, log 10, POW, sine and cos. Okay, now then there are other functions such as tan, then degrees or radians, f mod and factorial and GCD. Okay, now as their name suggests, these functions do exactly what their name suggests, except for ceil and fab. Ceil basically returns the smallest integer, not less than the number which is giving an argument. For example, let's say if I were to give you an argument of math.ceil, or as I said m. All these functions are used with an m dot prefix for these functions to work, because all library functions work that way. So if I want these functions to work, I use an m dot before all of these functions, since they are library functions. So m dot ceil would basically convert my number to the smallest integer, not less than the number that we have already been using. For example, I were to give you m dot ceil, and in the argument I was to give you 1.03. Then my answer that I would get would be 2. So basically rounds it off to the closest greatest integer. Okay. Then math.sqrt gives us the root of any argument that we have given. Then math.exp gives us the value of the exponential value of any number. Let's say natural logarithm of e raised to the power of the argument. Let's say math.exp or m.exp 2. So we will get the value as e to the power 2. Okay. Then there is fabs. Fabs basically gives us the absolute value. So in math, when you put a mod, you get the absolute value. Fabs does the same thing. For example, I was to give an argument of minus 1.0, I get 1.0 as my answer. Then log gives you the logarithm value. Okay, any logarithm value according to the base. We give two arguments in this. We give the number and then to what base we are going to give the logarithm value for. Then log 10 gives any number with the base 10. The log value of any number with the base 10. Then power, it gives us the value of a number raised to some power which is also given as argument. The number and the power, and then we get the answer. For example, let's say I would say m dot POW in brackets 3 comma to the power. Let's say I want to raise it to the power 3. So 3 comma 3. So 3 to the power 3 would be 81. Correct. 3 to the 9 and 9 to the 27. So it would be 27. Okay. Then sine, cos, tan, all these values give us the values of the argument given, the sine value, the cos value, and the tan value of any argument that we have passed. Similarly, degrees and radians basically gives us the degree value of any x angle which is converted from radians to degrees, and radians does the opposite, which is it converts degree values to radians. Then we have f mod. This gives us the modulus value of any, let's say, modulus value means the remainder value. We use the mod operator for giving for the remainder value. This does the same thing. Then there is factorial, which returns the factorial of a number, and then there is greatest common divisor or greatest common factor, which gives us the highest common factor of any two numbers. That pretty much sums it up for today. We'll continue with the statistics module tomorrow, and we'll also move on to statement, the flow of control in Python and how there are a lot of operators are executed and a lot of stuff. Okay, so that's all for today. Bye bye. See you later.